Okay, we're on lesson 5.3, solving systems of linear equations by elimination. We're going to fill in our vocabulary word. Coefficient is a number placed before and multiplying a variable in an algebraic expression. So we're going to look at the steps. So we have 4 steps. We're going to multiply, if it's necessary, one or both equations by a constant. So at least one pair of like terms has the same or opposite coefficients. Then we're going to add or subtract the equations to eliminate one of the variables. We will solve the equation for the remaining variable and substitute the value from step 3 into one of the original equations because we want our answer in the form xy. So we're going to move down to example 1. When we look at example 1, these are set up to eliminate. We have x plus 3y equals -2 and x minus 3y equals 16. So I am going to add, because 3y and -3y are opposites, I can eliminate them. X plus x is 2x, and -2 plus 16 is 14. So now I need to solve for x. X equals 7. Now I need to plug that value back into the equation, one of the two equations, and solve for y. So I'll use the first equation. X plus 3y equals -2. It doesn't matter which equation you use, just pick one of them. 7 plus 3y equals -2. Subtract 7. 3y equals -9. And y equals -3. Now you can check that answer and make sure it satisfies both equations. Try these next two on your own. Pause the video and we'll pick up on the next page. Example 2 is a little bit different. If you notice the first system, we have -6x plus 5y equals 25 and -6x minus 12y equals 42. So we have two identical terms, the -6x and the -6x. So if we multiply one of those equations by -1, we will have opposites that we can eliminate. So I'm going to show that I'm multiplying every term by -1. Ooh, that -1 looks bad. Okay, so I'm going to bring that down. And -6x times -1 is positive 6x minus 5y equals -25. And the other equation gets to stay the same. -6x minus 12y equals 42 because those are opposites. Sometimes I put things into columns so I can keep the signs in order. And now I can see in my first column I have opposites. 6x plus -6x is eliminated. And -5y plus -12y is -17y. And -25 plus 42 is 17. And if I divide by -17, I get y equals 1. Now I need to plug that 1 in to one of the two equations, -6x plus 5 times 1 equals 25. -6x plus 5 is 25. -6x, oh, I gotta subtract 5. -6x equals 20. Guys, I made a mistake. My y should be -1. I knew I wasn't coming up with the right answer, so I need to go back and fix that. 5 times -1, so that should be -5. So -5, so now I add 5. Oh, whoops, even teachers mess up. So now I'm going to divide both sides by -6, and x equals -5. Okay, that's more like it. Sorry about that. We do the same process for example 2. So I need to multiply the first equation by a -1. That's the bell. I'm going to pause my video. I'll be back in a second. Okay, we're back with the second example. If you notice, our y values are the same, so we're going to multiply one of them to make sure we have opposites. So I'm going to put a -1 times -1 times -1. So that first equation is going to be 3x minus 10y equals +1. And the other equation is 12x plus 10y equals -46. So if you look closely, the y values are opposites, so I can just eliminate those. So 3x plus 12x is 15x, and that equals -45, because that's 1 plus -46. And now I need to divide by 15. So that means x is -3. Now I need to plug -3 into one of the two equations, so I'll use the first one. -3 times -3, I'm substituting that in for x, plus 10y equals -1. 9 plus 10y equals -1. I'm running out of room a little bit. So subtract 9. 10y equals -10, and divide by 10. So y equals -1. I'm going to scroll back up and put this into my answer. Okay, you are going to try on your own questions. Look for numbers that will easily be changed into an opposite. And remember that when you multiply that equation, you multiply all three parts of it by your -1. Our last example is a real life application. So remember that we're going to decide what our two variables are. We're going to write two equations and we're going to solve with elimination. So here's our example. You buy 24 hostas and 45 daylilies for $579. Your friend buys 24 hostas and 96 daylilies for $936. Write a system of linear equations to find the cost of each plant. So I'm going to say, and I'm going to save myself some room by putting it up here, that H is a hosta and D is a daylily. Now my first equation is 24 hostas plus 45 daylilies for $579. The other equation is 24 hostas plus 96 daylilies for $936. Now, if you notice, our hostas are the same number, so we can multiply the first equation by -1 or the second equation by -1 and get opposite values. So I'm going to multiply the first equation by -1. Notice I write it 3 times so that I can see it. So negative 24h minus 45d equals negative 579. Now, I'm going to add that to the other equation that didn't have to change. 24h plus 96d equals 936. And now my hasas will cancel. And I'm going to find the difference between 96 and negative 45. When I subtract those, I get 51d equals the difference there is 357. Now I'm just solving a one-step equation, so I divide both sides by 51. So I get 7 daylilies. Now I need to plug that 7 into one of the two equations. (24h) plus 45 times 7 equals 579. Okay, now we have 24h plus 315 equals 579. Now subtract 315. (24h) equals 264. Running out of room. Divide both sides by 24. I'm out of room. H equals 11. So that's the first part of my answer, and that's the second part of my answer. Do the same thing down below. I noticed that both landscapers are buying 20 peonies each, so you're going to multiply one equation by -1, and you will be able to eliminate the peonies.